is it's a lot of square root stuff. Now, what is going to give people a lot of trouble is that you're probably not going to have a calculator on these sections, so you're going to have to do all this stuff without a calculator. All right, now I know that sounds scary, but we're going to talk about how we can do it without a calculator today. So I would definitely pay attention, especially if you used the calculator when you were going through this, right? So number one is really tricky. Number one is kind of like a magic trick of a problem. We have to find the fraction equivalent to 0.4. What does that little line on top tell me? That it repeats forever. 0.444 dot dot dot, right? Well, how would I be able to write that as a fraction? Well, what we can do is we can say that x is equal to 0.44 repeating. Okay, we can say x is equal to anything because x is a variable, right? If x is equal to 0.44444, what is 10x equal to? Well, what's 10? 44, very close. It's going to be 4.44 repeating forever, right? If I multiply something by 10, I'm just moving the decimal over one space. You guys know that? Yeah? So 10x is 4.44, right? Well, if I do 10x minus x, what is 10x minus 1x? What would that give me? If I have 10 x's and I take one away, how many do I have left?
9.
Okay, 9x, right? Well, if 10x is 4.44, right, I'm going to substitute that in. And x is 0.44 repeating. What is 4.444 minus 0.44444? Just 4, right? The repeating decimals go away. And that just leaves me with 4. You guys following that?
Yep.
Okay. So this expression here, 10x minus x, is the same exact thing as this expression here. So I could say that 9x is equal to 4. I'm just substituting those two things that we figured out into each other. How can I solve for x now? Divide by 9. Okay, so x is equal to 4 over 9. There's my fraction. If I then, you're not going to have a calculator, but if I wanted to check this, 4 divided by 9, oops, what the heck? 4 divided by 9 is 0.44444. All right? Now, this is kind of a lot of stuff to remember. If you do end up seeing a question like this where you have to write a repeating number or a repeating decimal number over a fraction, just put the number, see it's 444, the 4 is repeating, just put it over 9. Watch this. 5 divided by 9 is 0.55555. 8 divided by 9 is 0.8888888. 1 divided by 9 is 0.1111111. Yeah.
So whatever number we get, we just divide it by 9.
Exactly. That's all it is. I'm not sure if you're going to see that question, but in lieu of doing all this work, because this is kind of a lot to remember, this is like a process you'd actually have to memorize. If I see a repeating decimal, I'm just putting it over 9. So 4 over 9, 5 over 9, blah, blah, blah. Yeah, Alicia? Like if it was just say how to write 0.4 with no repeating, well, that would just be 4 over 10. That's much easier, right? If I have 0.56, well, that's 56 over 100. Oops, 56 over 100. Right, it's like a percentage. Okay? So that one, I told you guys to skip that one yesterday because there's no way you would know to do that. But that is how we would do it, just in case you do see it next week. All right? Now, with the square roots, right, it's really easy to plug in the square root into a calculator and get a decimal number and be able to figure out where it is. If we don't have a calculator, the best we can do is estimating. Do you guys remember how to estimate a square root?
No.
No? I appreciate your honesty. Estimating a square root is like if I have the square root of 7, what's the closest perfect square to 7? Perfect square is 1, 4, 9, 16, 25, 36. What's the closest one to 7? 4 and 9. Right? So the square root of 7 is somewhere in between 4 and 9. What's the square root of 4? 2. What's the square root of 9? 3. So the square root of 7 is between 2 and 3. Do you guys remember that now?
Well, yeah, I
Yeah.
was going to say that, but I thought it was wrong.
No, you're right. Estimating is when we're figuring out where it falls in between, right? So if I have a number like the square root of 7 over 10, well, this question is a little bit different, but we'll get to the estimating stuff. Like if we go over to number 3, right? If I have the square root of 5, same thing. It's in between the square root of 4 and the square root of 9. So it's in between 2 and 3, right? Between 2 and 3. So it's going to be 2 point something. Now this says square root of 5 is less than 2.9. If I know that it's in between 2 and 3, do I know right away whether that's a true statement or a false statement? No. 2.9 is also in between 2 and 3, right? But where in between 2 and 3 is it? Again, I could plug it in the calculator and figure that out easy, but if I don't have a calculator, what I can do is this. Here's 4, and there's 9, right? If this was a number line, we've got 5, 6, 7, 8, 9. No, right now. 5, 6, 7, 8, 9. The square root of 4, right, is right here. The square root of 9 right there. Is 5 closer to 4 or closer to 9? Closer to 4. So the square root of 5 is going to be somewhere in here. Right? 2.9 is almost 3. That would be like right there. So the square root of 5 would definitely be less than 2.9. Does that make sense at all?
Yes.
Kind of? No? So if I have like, let me show you like this. Square root of 4, square root of 9. In between those, I have the square root of 5, the square root of 6, the square root of 7, and the square root of 8. Right? This is 2, and that's 3. Does that make sense? So 2.5 would be like somewhere in here, in between 6 and 7. 2.25 is probably over here, the square root of 5. And if I took 5 and square rooted it, I get 2.24, which is almost exactly 2.25. Square root of 8 is probably 2.75. So if we space the square roots out at the same intervals that we space out a normal number line, we can estimate where certain things are going to be. 2.9 is going to be way up close to there, but the square root of 5 is over here. So which one of those is smaller, the square root of 5 or 2.9? Square root of 5. It's further to the left, right? For this one, 4 is greater than root 23. Well, where does the square root of 23 fall in between? What's the closest perfect square to 23? 25. So it's in between 16 and 25, which means this is between what? 4 and 5. So the square root of 23 is 4 point something. It's way closer to 5, so my decimal is going to be bigger. Let's just say it's 4.8. Is 4 greater than 4.8? No, 4.8 is greater. So that second one would be false. Right? So we can use our estimating what we know how to do to kind of logically break down. We're not getting an exact answer. We don't need an exact answer. We just need to know in relation to the other numbers, where does that number fall? Yeah. Go ahead. Zach? And then the last one, the square root of 30. Well, that's a little bit more than 25. So 30 is going to be like 5 point something, right? Let's say 5.2 over 5. Is 5.2 over 5 less than 7 over 5? Yeah, so that one would be true. You guys know how I got 5.2? Yeah? Okay. Good morning, Joanne. We just started going over the worksheet from yesterday, okay? All right. Now this one, rational, irrational, this one's much easier, right? I don't need to simplify. I don't need to solve anything out. I just need to know, is it or can it be written as a fraction of 2 integers? What's an integer again? That's right. Any number that we see on the number line. So there's no fractions, no decimals, but there's positive whole numbers and then negative whole numbers, right? That's what an integer is. So 1 over 2, can that be written as a fraction of two integers? Yeah, 1's on the number line, 2's on the number line. That's definitely rational. Is the square root of 7 on the number line? No, that's irrational. Is 3 pi on the number line? No, irrational. What about 5 and 9? Yep. And 18? Yes. Let me ask you this. What about the square root of 36 over 7? Is that rational or irrational? Rational. Why is it rational? Square root of 36 is on the number line? Where is that on the number line?
All the way. It never stops.
Well, yeah, but I'm looking at just this number line, right? Where's the square root of 36 at? 6. We could simplify this to 6 over 7. Boom. That is rational, right? So it'll try and trick you and give you a square root that can be simplified. If it's a perfect square, then it's still a rational number. Square root of 7. Is 7 a perfect square? No, right? So that's how we know whether it's rational or irrational. Anytime you see pi, immediately gross, that's going to be irrational. There's nothing we can do with that. But in terms of square roots, if it's a perfect square, it's rational. If it's not, irrational. Pretty straightforward, right? Jumping down real quick to number 5. What's 14 plus 7 plus 23? 21 plus 23 is 44. What two perfect squares does that fall in between? Well, yeah, 36 and 49. So somewhere between 6 and 7. Which one of these answer choices gives me an option between 6 and 7? A. Easy. But when we get down to number... Oh, there is no number. 7, right below it, it's the same idea, right? What's 25 minus 4? 21. 21 plus 16? 37. Well, this is between 6 and 7 as well. 36, 49, between 6 and 7. Which of my answer choices here are between 6 and 7? A and B, right? This is in between 6 and 7, and this is in between 6 and 7, right? You guys see that? So C and D are out. We don't need those. Now it's between which one of these is more correct. Well, this is where we have to do that number line thing that I just talked about. If I have the square root of 36 and the square root of 49, right? Where would the square root of 37 fall in between these two numbers? On the left side or on the right side? On the left, way over here, square root of 37, it's just slightly bigger than the square root of 36. Well, what's the square root of 36? 6. And the square root of 49 is 7. So the square root of 37 is going to be very slightly above 6, maybe like 6.1 or 6.05 or something like that. So between A and B, which answer is more accurate for us? A, right? So not only are we now finding where does it fall between, but kind of on what side or where are we getting it close to. I'm not finding an exact decimal. I don't need a calculator to do this. I'm just logically deducing, all right, if the square root of 36 is 6, the square root of 37 is going to be just a little bit more than 6, right? So obviously 6.9, way too high. Okay? Does that kind of make sense? Closest approximation to the square root of 51. Same idea. I don't need a calculator. Where does 51 fall between? What's the closest perfect square to 51? 49 and 64? Right? Is it closer to 49 or closer to 64? Way closer to 49. So should I approximate this to 7 or 8? 7. Right? No long, crazy decimals, no calculations needed. I'm just rationalizing where this number is in relation to my whole numbers, okay? Number 4 is really hard. We're going to skip it. Let's go to the back. Oh, perfect. Same idea. Now, this one is slightly harder than the one we just talked about, number 6 on the front. The square root of 83. Well, let's do what we've been talking about. What's the perfect square What did I say? What's the perfect square? What's the closest perfect square to 83? 81. And 100, right? Now check this out. This is in between 9 and 10, right? Right away, C and D are gone. But A and B are really close together. How am I supposed to know if it's 9.1 or 9.2 without a calculator? Well, let's find out. 81, 83, and 100. I'm going to put those on a number line. 81, 83, and 100. How far away from 81 is 83? 2. How far away from 81 is 100? What's 100 minus 81? 19. Right? So I know that this is going to be 9 point something. But I don't have a calculator to figure out what that point's going to be, whether it's 1 or 2. If I take the distance from 81 to 83 and divide it by the distance from 81 to 100, that's going to give me my decimal right there. So 19 goes into 19 going into 2. I need a decimal space with a 0. How many times does 19 go into 20? 1 time. 1 times 19 is 19. Subtract that and get 1. You guys remember how to do long division by hand?
Yeah.
Hopefully. I add another 0 and bring it down. How many times does 19 go into 10? None. So that's 0. What is my decimal going to be now? 1. 9.1, right? So my answer is going to be A. Okay? Let's go to the calculator and check that out. If I take 83 and I take the square root, am I going to get 9.1? Yes, I am. 9.11. Now, the decimal we found is not exact, but it's within a close enough margin that we can confidently say that's my answer, okay? All right? Does that one make sense? A little bit? Okay. Okay, same thing here with number 9. I've got to approximate 2 times the square root of 29 to the nearest tenth. So I need 1 decimal place. Well, let's take a look at the square root of 29. What are the 2 perfect squares closest to 29? 1, 4, 9, 16, 25, 36, 49, 64. 25, good. And 36. So it's going to be in between 5 and 6. I know it's going to be 5. Oh, sorry. The square root of 29 is going to be in between 5 and 6, right? Where in between? I need a decimal, so where is it going to be in between? How far away from 25 is 29? 4. How far away from 25 is 36? 7. 11? 25 to 36. Sorry, not 29 to 36. From 25 to 36 is 11, right? Well, let's do 4 divided by 11. How many times would 11 go into 40? 3 times, 33. Minus 7, bring down the 0. 6 times into 70, 66, blah, blah, blah. 4, 0, bring it down, 3 again. All right? So 0.363. So I could say the square root of 29 is equal to 5.363. Is that going to be my answer here? No. I got to do what? Estimate it? Well, I've got to get it to the nearest tenth, but is it just asking me for the value of the square root of 29? Or is there something in front? There's a 2. 2 times the square root of 29. So if the square root of 29 is this, 2 times this is 10.726 or 10.7. Is that right? I feel like that's wrong. Let's see. If I do the square root of 29 times 2, oh yeah, 10.7 or 10.8. I guess it could go either way. It depends on when you round it. Like if I had rounded this to 5.4 and we multiplied it by 2, then we'd get 10.8. But it should be fine either way. Now, what is this little thing? What is that guy? You see that? What is that number on top of the little square root? What is it? It's a teeny tiny 3. Now, this is something we didn't talk about, so this is going to be new information I need you guys to hear, all right? Normally, if I were to take the square root of 94, right, this is a square root, okay? So when I do a factor tree and break this down, what am I looking to circle up and bring outside of my root?
Pairs.
Pairs, because a square has 2 dimensions. It has a length and a width. Everybody with me on that? Yeah. This is different. This is called a cube root. How many dimensions does a cube have? 3 dimensions. So if I were to break this up, in this case, I'm not circling up pairs. What do you think I'm circling up?
3 numbers.
Triplets. I'm looking for trios. For example, if I have the cubed root of 8, well, what 2 numbers multiply to give me 8? 2 and 4. What 2 numbers multiply to give me 4? 2 and 2. So I have the cube root of 2 times 2 times 2. Are there any triplets I can circle up here? Yeah, I've got a trio of 2s. Is there anything left behind? Nope. The 2s come out, and they all fuse together to a single 2. So it's exactly the same thing as a square root, but instead of pairs, we're pulling out triplets, okay? So that's what a cube root is. I'm trying to approximate the cube root of 94. Now, this is difficult. What I'm going to do here is I'm going to work my way backwards. I'm going to cube all of these answers and see which one gets me the closest to 94. All right? What is 5 times 5 times 5 equal to? Well, 5 times 5 is 25. What's 5 times 25? 125. What's 10 times 10 times 10? 1,000. 31 times 31 times 31, that's going to be an insanely large number, way larger than 94. So what's going to be the closest number to 94? 125 or 1,000? 125. So my answer must be A. Right? I didn't even touch the cube root. All I needed to know was that I'm cubing my numbers to hopefully get me close to 94. All right? Almost done. The closest approximation to 253, what's the closest square root to 253? Oops. Closest perfect square to 253? 256. What's the square root of 256? 16. This is just slightly smaller than 16, right? So we can approximate this is probably 15.9. Is that closer to 15 or 16? Closer to 16. So my answer is going to be B. Right? I'm not doing any exact math. A lot of this, almost all of this, is just estimating and using logic to figure out what's the best answer. All right. 12. Again, 5 is greater than x. Oh, is that an x? No, I'm tripping. That's a pi. Well, what is pi equal to? 3.14. What is 3.14 plus 3? 6.14. Is 6 greater than 6.14? No, that's false. Good. What's the closest perfect square to the square root of 5 here for the second one? Square root of 4. So we could say the square root of 5 is just slightly larger than 2 because the square root of 4 is 2. So the square root of 5 is maybe like 2.2. Is 2.2 greater than 5? No, that's false as well. What about the square root of 17? What's the closest perfect square to 17? 16. Well, what's the square root of 16? 4. So the square root of 17 must be slightly bigger than 4. Let's just say 4.1. Is 4 greater than 4.1? No. So that one is false as well. You guys kind of getting this a little bit?
Yes.
Okay, cool. And last but not least, let's do, what is 16 plus 4? 20. What's the closest perfect square to 20? Probably 16 and 25, right? Now I need the nearest tenth. I need a decimal. So I'm going to do my little, I'm going to set up a fraction here. How far away from 16 is 20? 4. How far away from 16 is 25? 9. 4 divided by 9. Where have I seen 4 divided by 9 before? The very first problem. I know that 4 divided by 9 is 0.4444444. So the square root of 20, if it's in between 4 and 5, it's 4.444444. Right? If I were to take a calculator, do 20, and find the square root, 4.47, but to the nearest tenth, 4.4, we got it right. All right? How does that sound? Good? Not good?